All right, assignment 3-6, working with antiderivatives. Sometimes you have to make it look friendly. I wrote down these questions already. It'd be wise for you to press the pause button and try it first, and then press play. How do I do the antiderivative here? First, I'm going to write it as x to the negative 3. That's friendly. Add 1 to the exponent, divide by that exponent, plus c. Again, algebra. How do I make this look friendly? That's t to the exponent 1/4. And then we're going to add 1. So 1 plus 4 is 5. And then divide. I like practicing the reciprocal. So instead of dividing by a fraction, multiply by its reciprocal. And then plus c. To make this friendly, and again, you should press pause, right? Like, I realize that it's going fast if you don't press pause. We need to FOIL this first. So if you FOIL it, it's x squared. 1 minus 2x is negative 1x, and then 1 times negative 2. And then after you FOIL, we're just going to add 1 and then divide, add 1 and divide. That's minus 2x and then the candy. Press pause. Write down number 4. We're going to simplify this. So a good first start is to write it as to the 1/2. Recognize that they have the same base. The exponent you don't see is 1. We're going to subtract. So if I subtract it, that's 1/2. 1 take away a half. And then we're going to add 1 to the exponent. That's 3/2. And then divide or times the reciprocal. I want you to get used to that. Plus the candy. So that's really 4/3. Y to the 3/2 plus c. Press pause and write down the question. Try it and then press play. This one's already ready to go, so we're going to add 1 to the exponent and divide. Add 1 and divide. 1 is just x, and then plus c. Again, press pause, write down the question, try it, then press play. We're going to write this as 1/3 x to the negative 2. And so then the answer is 1/3 x to the negative 3. Divide by negative 3. That's the same as negative 1/9. And then don't forget the candy once you integrate. Oh, I didn't add 1 at all correctly. What's negative 2 plus 1? That's negative 1. Divide by negative 1. That makes this negative 1/3. I bet you saw that. Silly. Now we're better. This, if I square this, you should press pause, write down the question, do it first. Square this, it's 1/9 x to the negative 2. See if I make the same mistake twice. Add 1, divide, so it's really negative 1/9 x to the negative 1 plus c. Press pause, write it down, do it first. Yep. We're going to write this friendly. So that's, as a fraction, this would be 2/5. And then integrate it. So if I add 1, 2 plus 5 is 7/5, and then the reciprocal, plus c. Pause, try it, then press play. Here we go. All right, this one's ready to go. Number 9. So if I add 1 to the exponent, that's 5/4, the reciprocal. Add 1, that's 1/3, the reciprocal. And then the 5s do cross out here. So it'd be just 4x to the 5/4 and so on. Number 10, we're going to FOIL. So 3t times 3t is 9t squared. You could draw a box or FOIL, write it twice. This would be negative 30 and negative 30. And then negative 100 squared is plus 100. And then integrate each one separately. So this would be 9t cubed divided by 3, negative 60t squared divided by 2, 100t plus c. And yeah, you could write it as negative 30 or positive 3, but it's not necessary. Number 11, some trigonometry. So the antiderivative of sine is negative cosine. The antiderivative of cosine is positive sine. That is going to take practice. to remember your rules. The antiderivative of secant squared is tangent. Theta would just be theta, add 1 to the exponent and divide. And then 2 would just be 2 theta, and then the candy. Here we need to simplify it. Press pause, write it down, do it first. 8 divided by 2 is 4, and then subtract the exponents. Negative 2 divided by 2 is negative 1. Oops. And the x squares would cross out. And then there's 1/2, and it's x to the negative 2. So do we have that skill building to simplify this so that I can then integrate it? So again, I'm going to add 1 to the exponent and divide. Negative 1 would just be negative x. Add 1 to the exponent and divide, which would make this negative 1/2. And then don't forget the candy. Again, I need to simplify this. So if I divide by root t, I just have 2. But if I go 1 divided by root t, that's t to the negative 1/2. And then integrate it. Add 1, negative 1/2 plus 1 is positive 1/2, and then the reciprocal, and then the constant. This I'm going to distribute. Think of this as y to the 1/2, and think of this as y to the 1/2. So when I multiply, I add the exponents. So 1/2 plus 2 would be 5 over 2, or 2.5. Oops, I need y to the 5 over 2. Multiply 1/2 times 1/2, that's add them, and that's just y, or y to the 1. And now it's ready to integrate. So now we're going to add 1 to the exponent, 5 plus 2, and then the reciprocal. We're going to go add 1 and divide, and then don't forget the constant. And that could be written just as y squared. 16. The integration of cosecant squared. That's negative cotangent, right? That's one of the rules. So that's negative cotangent. Negative 2 theta would be negative 2 theta squared divided by 2, and then the constant, and the 2's could divide out. Number 17, again, press pause, write it down, do your best, then press play. I'm going to multiply this through. Secant times secant is secant squared. Secant times tangent is secant tangent. Did I mix up the variables? Is it x or theta? It's x, right? Let's not mix up the variables. And now, secant squared is a rule. That's tangent when you do the antiderivative. Secant tangent is a rule. That's secant. And then don't forget the constant at the end. Number 18. All right, switching gears here a little bit. So we're going to do the antiderivative and then plug in to find what c is. So the antiderivative here, you add 1 and divide. You add 1 and divide, and then don't forget the constant. So we do the antiderivative. Now we're going to plug in 1. The 3's do divide out. 4 divided by 2 is 2. And make it equal to negative 3. So this is negative 2 plus 2. So I just got to subtract 1 to both sides. So c is equal to negative 4. And then rewrite it. So it's x cubed minus 2x squared plus 2x minus 4. With the constant. Don't forget to rewrite it. Don't end with what c equals. Number 19. Again, press pause, write it down, do your best, then press play. So again, I'm going to do the antiderivative here. So I'm going to rewrite this a little friendlier. So that's negative 3t to the negative 2 plus 1. And then I'm going to add 1 to the exponent. When I divide by negative 1, it becomes positive 3. 1 is just 1t and the constant. At this point, we can plug in the point. So y is 10 and t is 3. And then I need to simplify it. So 3 to the negative 1 means 1/3. The 3's cross out, that's 1 plus 3. So the 3's cross out, and 1 plus 3 is 4. So subtract 4, and C is equal to 6. And then again, don't end there. Write down what it's equal. So the function's in the form of y equals. So we write down y equals, right here, 3t to the negative 1 plus t plus 6. Because now that we know what c is. Number 20. In number 20, find an equation for the family of functions. So I'm given the derivative, 3 in the square root of x. I'm going to write that friendlier. Oops, just 1/2. I'm going to do the antiderivative of that. So I'm going to add 1 to the exponent, and then the reciprocal, and there's a 3 there. So the 3's cross out, and I get 2x, 3 over 2 plus c. That's the answer for A. And then for B, it says to plug in something, right? 4, 0. So if I plug in 4, 0, x is 4, and y is 0. This is good practice. How do I do that? So the square root of 4 is 2, and 2 cubed is 8. So that's 16. So you subtract it to the other side. So c is equal to negative 16. Don't end there. So then what's the equations? 2x to the 3/2 minus 16. That's where you end. Number 21. Find g at x given the second derivative is 2x subtract 3. The first derivative at 0 is equal to negative 5, and g at negative 1 is equal to 2. All right, one step at a time. So we're going to integrate the second derivative. That's going to give me the first derivative. If I integrate this, I get add 1 and divide, and then don't forget the constant. So I'm integrating this to find the first derivative. Now plug in. So plug in 0 and negative 5. If I do that, plugging in 0 is really simple. 0, 0, all I'm left with is negative 5 for C. So it's x squared minus 3x subtract 5. If I want to find what g is, I then integrate the derivative. So I'm going to integrate the derivative. That gives me g. So again, add 1 and divide. Add 1 and divide. And the constant. So we have x cubed over 3 and minus 3x squared over 2 minus 5x plus c. So again, I have a point to plug in. So it's going to be equal to 2. And put in negative 1. And then solve for c. So this is negative 1/3. This is negative 3 over 2 plus 5. So I'm going to subtract 5 first. Common denominators would be 6. So this would be 2 over 6, and this would be 9 over 6. So it's 2 and 9. That's negative 11 over 6. And then add that to the other side. Again, common denominators with a 6. So that's negative 18 plus 11. That's negative 7 over 6. Don't end there. So our end is writing the equation over again. I know I'm running out of space here. I'm going to do it up here. And there's your answer. 22. For number 22, you have the second derivative, the first derivative, and what you're asked to do is to find f of x. So again, we're going to work backwards. So we're going to integrate to find the first derivative. So the integration of sine is negative cosine plus c. We're going to plug in 0 for x and make it equal to 2. Now, for this situation, cosine at 0 is equal to 1. So this is negative 1. So when you add it, it's equal to 3. Rewrite it. So that means the derivative now is negative cosine x plus 3. Then we're going to integrate that to find what f of x is equal to. So f of x, the antiderivative of cosine sine, but it's negative sine because there's already a negative in front. And 3 is just 3x, and then the candy. And then we're going to plug in 0 and 2 again. 0, 2, 0, 2, yeah. So if you plug in 0 again, now when you plug in 0 for sine, the value of sine at 0, is 0. Again, we're going to make it equal to 2, right? So this is all 0, 0, 0. So c is equal to 2. Don't end there. So the function then would be negative sine x plus 3x plus 2. And now it's done. 23. The derivative and integration undo each other, so all I'm left with is 2x minus 1 cubed plus c. Sorry, I don't even need a plus c, right? I think they just undo each other. Yeah. So they just cross out, and there's your answer. 24. So to find f of x, we're going to do the antiderivative of each step. So we're going to add 1 to the exponent, and when you divide, 2 divided by 2 is done. 8 would be 8x, and then the candy. Here we have add 1 and divide, so it's x cubed, because when you divide by 3, the 3's divide out again. And we have 2 constants, so I'm going to label them differently. And then we're given a point, 1, 1. So if I plug in 1, 1, that belongs to the top piece because 1 is less than 2. So I'm going to plug 1 in for x and make it equal to 1. So this is 9. And when I subtract 9, that's negative 8. So now I know the top piece. I'm running out of space here. So I found the top piece. Now, it says in the question that it's continuous. No, it's differentiable. So if you can take the derivative everywhere, that means it's continuous. So that means I can make them plug in 2 and make them equal to each other to find the other constant so that they're continuous. So this is 4, 16, 20, take away 8. 2 cubed is 8, subtract 8. And the other constant is 4. Don't end there. So the very end of the question is here. Write down the equation. And now you have all the constants. And that's what you were looking for. All right, press pause, write down the next question. Then press play. The position of an object or particle is given by this. And it says find the velocity. So we don't want to get confused. We're not integrating now. To find the velocity, you take the derivative, and the derivative of 2 is 0. To find the find when the particle is moving left, you make it equal to 0. Oops, let's do that in part B. Make it equal to 0. We're going to solve this by factoring. And then when you make it equal to 0, the two answers are 0 and 3. Oops. So into the velocity, if I plug in a negative answer, a negative squared is positive times a negative, which is negative. It's squared at 0, so the sign stays the same. It has an odd multiplicity, so the sign changes. And so you can see that it's moving left when t is less than 0. It is stopped at 0 for a moment. Part C, find the velocity when the acceleration is 0. So the acceleration is the derivative of this, 12t squared minus 24t. The acceleration is 0. Make it equal to 0 and factor. So that's at 0 and 2. So we know at, and it says find the object's position at it. So I need to plug in 0 into here, and I get 2. And I need to plug in 2 into the same thing, the position equation. So I plug it into the position equation, plug in 2. And the answer is negative 16. So if you plug 2 in and solve it here, you should get negative 16. Done. 26. You're given the acceleration of an object moving horizontally. There it is. And it says the initial position or initial velocity is 5, and the initial position is negative 2. So you're given 2 points to be able to work backwards. So to find the velocity, we're going to integrate this. You add 1 to the exponent and subtract. Negative 4 is negative 4t, then the constant. If I plug in 0 for t, I'm just left with 5 as the constant. So if I put this together, it's 3t squared minus 4t plus 5. So when you plug in 0, this is what you're left with. Part B, find the velocity when t equals 2. So then you plug 2 in here, and you get 12. Take away 8 plus 5, that's 9. C says find the position equation. That means I'm going to integrate this. I'll call it x. Did it say s? No, whatever. Integrate, so you're going to add 1 to the exponent. When you divide by 3, the 3's cross out. I'm going to add 1. When I divide by 2, I get 2. And then 5 is 5t, and then the constant. When I plug in 0, c is going to equal negative 2. And then part D is to find the position at 2. So then you just plug 2 into here, and you get the answer. And then I'll do it. So that's 8. 2. That's 8. 2 is 10. I get 8. And there it is. 27. Turn the page. This one's a longer assignment because it also has a lot of review to it. So it's kind of at the very end of the chapter. The last assignment's also kind of a review assignment as well as like practicing the lesson itself. So the velocity of an object, the square root of t plus 1 t is greater than or equal to 0. And it says find an equation for the acceleration. Well, that's the derivative. So if the velocity is t to the 1/2 plus 1, then the acceleration must be 1/2 t to the negative 1/2. And the derivative of 1 is 0. It says find the acceleration when the object at t is equal to 9. So you plug 9 in. Oops. This means the square root and then reciprocal. So the square root of 9 is 3 and then the reciprocal. So the answer is 1/6. Part C says the object's position is 20. So find the position equation. So to find the position equation, use x or s. What's the antiderivative of this? So you add 1 to the exponent, divide or the reciprocal. The antiderivative of 1 is 1t, and then the constant, and then you plug in these values. So we're going to make it equal to 20 and plug 9 in for t, and then go from there. So the square root of 9 is 3, and 3 cubed is 27. 3 goes into 27 9 times, it's 18. And this is 27. So when I subtract 27, I get -7. And then don't end there. So what's the actual position function then? So now plug in -7 for C, and then it's done. 28. A ball is thrown straight up. A ball's drop, sorry, for 28. 29 is thrown straight up. 28, a ball is dropped from a bridge 160 feet above a river. How long will it take the ball to hit the water? So acceleration of that is going to be -32. The velocity of that is -32 t plus a constant. The initial velocity is 0 because it just got dropped. So it's just -32 t. The antiderivative of that is t squared, and then divide by 2. And now plus the initial position. And so it got dropped from a bridge which is 160 feet above, so that's the initial position. How long until that hits the water? So make it equal to 0, and then solve it. So I'm going to add 16t squared, divide by 16, and square root. So the answer is the square root of 10. 29. A ball is thrown straight up from a height of 6 feet with a velocity of 64 feet per second. So we're just going to get right into this. How high will the ball go? So first of all, I'm going to use the velocity equation. So the velocity equation is -32t plus the initial velocity, which is 64 feet per second. I'm going to make it equal to 0 and see when the velocity is 0, because that's the maximum height of that. So if I solve this at 2 seconds, the velocity is 0. So if you think of it, that's when it stops and goes the other direction. The position equation is -16t squared. Just want to remind you, it comes from this right here. So this is what I'm using. So it's -t squared, the initial velocity, just plugging in the number. So for 29, the initial velocity was 64. So that's 64t. And it started at a height of 6. So then I can plug in 2 into this equation to see what that maximum height is. So if you did that and plug 2 in for that, you get 70 feet. 30. For the first 4 seconds of a race, a sprinter accelerates at a rate of 3 meters per second. He then continues to run at the constant speed that he has attained for the rest of the race. So the acceleration is a rate of 3 for the first 4 seconds. And then after that, he just maintains the speed he has. So the acceleration is 0 for the rest of the race. So write a piecewise function that represents the velocity So the antiderivative of 3 is 3t. This one's a little confusing. The antiderivative of 0 is a constant. So it has to be some, because the derivative of a constant is 0. We don't know what that constant is. And then it says, find V2, V4. It says find at a rate of 3 meters per second per second. So we don't have any information to find that constant right now. The initial, for a sprinter, the initial velocity would be 0, right? Because you're just starting, like standing, not running to begin with. So, oh, and I need a c here, right? Both of these need a constant. So if I plug in 0 for t, this constant is 0. And this is a continuous race. So if that's the case, I need to plug in 4 to the top. There's nothing to plug in at the bottom, but they have to be equal to each other. So the constant on the bottom then would be equal to 12. So if I put this together, I know this is a good challenge. It'd be 3t from 0 to 4, and then it would just be 12 after 4. And there shouldn't be an equal sign there, just greater than 4. Here, just greater than 4. So there's our velocity equation. And now it says find the velocity at different values. So what's the velocity at 2? So just plug it in. Now, I need an understanding that 2, it belongs to the top piece. So plug 2 in and the answer is 6. And the units are meters per second from the question. If I plug in 4, that again belongs to the top piece. So 3 times 4, that's 12. And then the last 6 belongs to the bottom piece. So after 6, it's just the answer is always 12. C. In C, it says write a piecewise to represent the position. So to write the position, we integrate the velocity. So to integrate this, it'd be t squared divided by 2. And then a constant. And then the bottom would be 12t and then a constant. So the initial position, if you plug in 0, the initial position is 0. And then because it's a continuous function, we can make them equal to each other. And then solve it. equal to 20. Does it say something about 20? Oh, we're going to plug in 4. Huh. For t, and then solve it if it's continuous. So that's 48. This is 16. 16 divided by 2 is 8, and 8 times 3, I get 24. So if I set this up, position, and then the other piece would be 12t plus 24. And then take the bottom piece when it says how far does the spinner run in the first 4 seconds, so the answer would be 24. That's for D, because that's the position. And then E says, so the position there is 24, so when you do that, that's what we found. And then E, how long will it take the spinner to run 100 meters? So for the first 4 seconds, we've run 24 meters, right? So how many meters are left? 100 take away 24. Or ultimately, we need to make it equal to 0, right? 100, right? So when is the position 100? So I'm going to subtract 24. Divide by 12. So that's 6, 7. That's really fast. $76 divided by 12. That's 6 and a bit. All right, and that's that's pretty fast, right? I think the answer, for some reason, the position in terms of it. Oh, I know what I did wrong. When I subtract 48, you get negative 24. Ha. Did you catch that? So that when I do this, this should be a negative 24. So when I do this, this should be a negative 24. It didn't make sense because it was way too fast. So that's 124 when you add it. And then when you divide, that's like 10 and a bit. So it's about 10 seconds. And that makes complete sense. So it takes about 10 seconds to finish it. All right, I might have to stop soon. Let me do one more, and then I'll do a second video to finish it off later. Okay, use the graph of the first derivative to graph the second derivative and the function. So what's the derivative of this is 0. So from negative 1 to here, where's my color? I'll use. So from negative 1, this is the second derivative. So from negative 1 to 0, the slope is 0. Then the slope is negative 1 up to 4. Notice that this is a hole here because there's a sharp corner there, so it's not. And then the last slope goes up 2 over 1. So from 4 to 6, the slope is 2. And there you go. So there's the, and then let's do some number lines. So for the first derivative, when I look off the graph of the first derivative, I see 2 and 5. It goes from -1 to 6, by the way. And then I see 2 and 5. It's above, and then below, and then above. So we have a maximum, and we have a minimum. For the second derivative, again, it goes from -1 to 6. We have 0 and 4. So we have no concavity. Then it's concave down. And then it's concave up in terms of it. So no concavity, concave down, and concave up. So what would that look like for a graph? This is where we're going to end. So the function, what would it look like? So again, it goes from -1, 1, 2, 3, 4, 5, 6. So from -1 to 2, it doesn't give me any points. So I'm going to do my own points. I know at 2 is a maximum. There it is. I know at 5 is a minimum. There it is. So the first part of the graph rises to 2, and it's a line. Because a line has no concavity. So the first part is a line up to 2, and then after 2, it goes down, and it's concave down, all the way to 5, or to 4. So at 4, I need a different point here in the middle. So it's concave down, and then it's concave up. That's not concave down, is it? So it's concave down. So it's concave down, and then concave up to 6. Ignore this little part. So it's concave down, and then concave up, and it ends at 6 with a low point at 5. All right, Mr. G Math, over and out. I'm proud of you. This wasn't easy. We're working together at it, trying to get stronger. I'll finish this assignment in part 2. Till next time.